I'm Cousin Lee. I'm a database specialist, solution architect. In today's fast-paced world, there are many mission-critical business applications with back-end Oracle database cannot afford significant downtime when migrating from on-premise data center to AWS cloud. In this video, I'll introduce a solution by using AWS Database Migration Service, capture changes feature, and Oracle Data Pump together to really achieve migrating your mission-critical applications to AWS cloud with near zero downtime. Now let me give you a quick overview about the solution. The first, we will use Oracle Data Pump to export existing data from the Oracle database running on-premises data center to RDS Oracle database in AWS cloud. Before we take the data pump export, we will get the current IC number, use this IC number as a flashback ICN in data pump profile. Once we import the data into the RDS Oracle database, next we'll use AWS Database Migration Service CDC feature to capture all those ongoing changes. After my RDS Oracle database is completely in sync with the database running on premises, we can choose in the least workload time to do the application cutover. With that, we achieve to use DMS to migrate the Oracle database to RDS Oracle with a near zero downtime. Now let's start our demo. For the demo purpose, I have the pre-demo environment set up. I first created a self-managed Oracle database on EC2 instance as source. I installed Oracle clients like Oracle Developer and SQL+. I created an Amazon-managed Oracle database RDS as a target. I created an S3 bucket for storing data pump files, which is integrated with RDS Oracle by using S3 integration feature. For the demo highlights, first, I will create a database migration service replication instance, create endpoints for both source and target databases. I'll go to the source database, get the current ISIN number, export source schema from a database on EC2 instance by using Oracle Data Pump. Upload the pump file to S3. I load to RDS Oracle instance by using S3 integration feature and import to target database. I will create database migration service CDC task, conduct a few tests to verify CDC task works fine as expected. Now let's come to the AWS Database Migration Service console. From console left-hand side panel, let's choose replication instances. As you can see, I already have a few replication instances up and running, but for this demo purpose, I'll create a new replication instance. Click the button. On this Create Replication Instance page, I'll follow instructions and step by step. First, I'll give a name for the instance called DMS demo, and description, this is for demo. For instance class, I'll leave default, but in your real world scenario, you should choose an appropriate instance class for your replication requirements. Each instance class will provide different level of compute, network, and memory capacity. For engine version, I'll choose 3.3.4, and allocated storage space, I'll leave default number 50 gigabytes, but again, you should choose appropriate storage space size because AWS DMS uses storage for log files and cache the transactions while replication tasks are in progress. For the VPC, I'll choose the default, and for the demo purpose, I'll choose single AZ deployment but in your production environment, we strongly recommend you to use multi-AZ deployment to gain high availability. Since my source database on the EC2 instance and the target is RDS Oracle, both are in Amazon VPC, so I will not choose publicly accessible. In the Advanced Security and Network Configuration section, Replication Subnet Group, I'll choose Default, and the Availability Zone, I don't have preference for now. VPC Security Group will already choose Default. For KMS Master Key, because to keep the data secure during migration, AWS DMS encrypts the storage used by your application instance using AWS KMS. Encryption requires an AWS KMS master key, and AWS KMS creates a default master key for you. But you also can have the option to create your own key. For the maintenance, it's okay. I will use the default maintenance window for now, and I will allow minor version automatically upgrade. If now, let's check everything looks okay. I'll click Create button. This will take a few minutes to be finished. Now our instance is created and status is available. We'll move to the next step. Let's back to the AWS DMS console. From AWS DMS console left-hand side panel, let's choose endpoints. On the endpoints page, there are endpoints created before, but for this demo purpose, I'll create 2 new endpoints. Let's click Create Endpoint button. On the Create Endpoint page, we need to decide endpoint type first. There are 2 types, source endpoint and target endpoint. A source endpoint allows AWS DMS to read data from a database on premises or in the cloud, or from other data sources such as Amazon S3. A target endpoint allows AWS DMS to write data to a database or to other data sources. For the demo purpose, my source endpoint from an Oracle database running on EC2 instance. For endpoint configuration, we first need to provide endpoint identifier. And from drop-down list, we'll choose source engine. For our case is Oracle. Then we'll provide my Oracle database running on the EC2 instance server name. The database port, I use 1521. For this demo purpose, I will not use a secure socket layer mode, but in your production environment, we strongly recommend you to use secure socket layer mode. Provide username and password. Of course, provide the seed and the service name. Next is endpoint specific settings. Actual connection attributes define the additional endpoint specific settings for AWS DMS. For example, you can use actual connection attributes to control the timeout settings or time zone settings of your endpoint. To add or modify actual connection attributes for your AWS DMS endpoint, you can use console, like now, or can use AWS command line interface. And for the demo, I don't have the endpoint specific setting. I'll leave it empty. For the DMS master key, by default is enabled. For the tags, you can add tags to organize your DMS resource, or you can use tags to manage your IAM roles or policies and track your DMS cost. For the demo, I will leave it empty. So next is a test endpoint connections. This is optional, but the purpose we want to make sure from our DMS replication instance be able to connect to this source endpoint. So let's test it now. VPC, I'll choose a VPC where is my replication instance created, and choose replication instance. Choose the one we created just now. And next, let's click Run Test. Now you can see the test is successful. Alright, let's click Create Endpoint button. Let's refresh. So now you can see we created our source endpoint. Next, let's create our target endpoint. Now let's continue to create our target endpoint. Click Create Endpoint button. On the Create Endpoint page, this time we'll choose Target Endpoint. Since Target Endpoint from RDS Oracle database, I'll choose Select RDS DB instance. From drop-down list, I'll choose my RDS instance, which is demo. And we notice most of the information automatically populated for endpoint configuration. For the demo purpose, I'll use Secure Socket Layer mode is known, but in your production environment, we strongly recommend you to use a Secure Socket Layer mode. Let me provide password. Same as the source point, I will leave the endpoint specific setting is empty for now, and the TMS master key use default, and text, I don't need to set up a text for the demo. And for the test endpoint connection, even is optional, but I want to test to make sure everything works fine. Choose a VPC and choose replication instance. Choose replication instance where I created in this VPC. Now I run the test. So test is successful. Great. Let's create endpoint. So now I can see my endpoint for target endpoint also created. I have my both endpoints created at this moment. In last step, we create two endpoints, one source endpoint from the Oracle database running on EC2 instance, and a target endpoint for RDS Oracle. In this step, we'll use Oracle data pump to export one Oracle schema. Before we're doing that, we'll get the current ISIN number first. The reason why we need this number, because later on we'll use AWS Database Migration Service, CDC, capture data change, to think source database and target database start from this ICN. Now let's log on to the source database running on the EC2 instance to get the current ICN number. I'll use the SQL plus command. Alright, I got the current ICN number. Let's copy this number. I will use this number to replace the flashback ICN in my par file. Now I'm good to go to use Oracle Data Pump to export a schema named HR from my source database. Alright, export the schema successfully finished. Now let's upload the data pump file to S3 bucket I already created. Alright, the dump file now is already uploaded to S3 bucket. Now let's come to the Amazon RDS console. From console, I'll choose RDS DB instance, which is my DMS target endpoint. On the summary page, scroll down. You'll see currently I have an IAM role assigned to this instance, RDS S3 integration role. This role allowing my RDS DB instance to be able to access S3 bucket where my Oracle data pump files were stored. Let's also come to the configuration page. From this page, you can see we have one option group assigned. Click option group. I have the two features now currently added to this option group, S3 integration and time zone. For making RDS DB instance be able to integrate with S3, we need to have S3 integration feature added to option group, which is assigned to RDS DB instance. And also, we need to have one IAM role allow DB instance to access S3 bucket. Now let's importing schema dump files generated from my source endpoints, which is Oracle database running on EC2 instance, to my target endpoint, which is RDS Oracle database. To do this task, I'll use SQL Developer. RDS Oracle database is a fully managed database. So first step, we'll use RDS Oracle database stored procedure called create directory to create a database directory. We'll use this directory to store dump files downloaded from S3 bucket. That's right. Successful. Next step, we'll use another store procedure called download from S3. As name described, this procedure will download dump files from S3 bucket, then stored into the database directory we created from previous step. That's right. We got the task ID. Let's copy this task ID and replace here. This is another store procedure called read text file. This procedure can allow us to read its log files about this download task from bdump directory. That's right. Now we get the content of the log file. This log file to tell us the task successfully downloaded the Amazon S3 object from bucket name Oracle data pump with the key, which is our dump file name, to the location RDS DB data. This location is RDS Oracle DB instance. The task finished successfully. We also can use another procedure called listdir to check the dump file stored into the database directory. That's right. And here we can see our dump file called HR dump and stored into this RDS database DB instance directory. Now everything is ready. We will use Oracle DBMS data pump API to import this dump file to the RDS Oracle database. That's right. Successful. Let's go to the database schema to verify. Let's refresh. Here we go. You can see the HR schema is imported. Click tables. We have the table showing here. We will also query the total number of the employees. We'll use this number to compare the record in the Oracle database running on the EC2 instance, which is our source database. So we got the total number of employees is 109. Now let's run the same query on the source database, which is Oracle database running on the EC2 instance. So we got the same record. That means we successfully use Oracle Data Pump, migrate HR schema from source database to the target database. After finishing initial data load, now I want to capture all those changes after the ICN number when I took HR schema dump and make sure my target database and my source database in sync. For doing that, let's back to AWS Database Migration Service Console. I will use AWS Database Management Service CDC task to capture all those data changes. From AWS Database Migration Service Console, from left-hand side panel, let's choose Database Migration Tasks. We'll create a new task. Click Create Task button. On the Create a Database Migration Task page, we will follow the instructions and step by step. First, we will provide a task identifier. And I'll choose replication instance created in the previous step. And same thing, and choose the source database endpoint and the target database endpoint. For migration type, here we can see from drop-down list, we have the 3 tabs. Migrate existing task. It will perform one-time migration from the source endpoint to the target endpoint. Migrate existing data and replicate ongoing changes. This not only will perform a one-time load, and also will continue replicate the changes from the source to the target. And replicate the data changes only. This will not to do the initial load. Will only move the changes from the source to the target. Since I already used the Oracle Data Pump, migrate HR schema from the source to the database, I only need to replicate all those ongoing changes. So I'll choose replicate the data changes only. In the task setting session, first we need to decide the CDC start mode. I'll use specify log sequence number. The reason why I choose this, when I use Oracle Data Pump, make the HR schema dump, I logged current ICN number at that time and put that number in Oracle Data Pump par file. Then I made the export. With that, I only need to replicate all the changes since this log sequence number. Let me get this number. For the CDC stop mode, I will use the default. And the target table preparation mode, I'll choose do nothing. I don't need to recreate table or truncate the data. And include log columns in replication. Don't include the log mode columns. Means AWS DMS ignore columns or fields that contain large objects. And limit log mode means AWS DMS truncate each log to the size defined by max log size. For performance-wise, limited log mode is faster than full log mode. And I will leave maximum log size 32K as a default. Since I only do the replication of those changes, I don't enable validation for this task, but I do enable CloudWatch logs. Component activities can be logged into the CloudWatch, such as source unload, target load, task manager, source capture, and target apply. The most important is source capture and target apply. If you from the job list, you can see they have different log level. For the troubleshooting purpose, obviously, you want to choose a detailed debug to give you the more detailed information to help you to troubleshooting what's the root cause. For the demo purpose, I will leave as a default. In the table mapping section, we can choose to use either guided UI or JSON editor. For demo purpose, I'll use guided UI. We need to first specify at least one selection rule with an include action. To do that, let's click Add New Selection Rule button. From here, choose a schema. For my case, my schema is HR schema. and I want to replicate all the changes happened every table under this schema, so I will leave wildcard for the table name. Action, we have the include or exclude. Include to migrate all selected objects. Regarding the transformation rules, we can use transformation rules to change or transform schema, table, or column names of some or all selected objects or other things. And for my case, I do need to add a new transformation rule. Because when we use Oracle as a target, AWS DMS migrates the data to the schema owned by the target endpoint user. For my case, target endpoint user is admin. To override this behavior, I need to provide a schema transformation rule. With that, I'll choose target schema, give the schema name is HR. My action is I want to rename to HR. We also have the pre-migration assessment. With the pre-migration assessment can warn you of the potential migration issues before you start in the migration task. So for the demo, I will not enable pre-migration assessment run. Then migration task startup configuration, I'll choose manually start later. For the details about all the settings, please refer AWS Database Migration Service User Guide. Now let's click Create Task. So now I have the task creation in progress. Now you can see I have the task successfully created. Now let's log on my source Oracle database running on the EC2 to make some changes. Before make changes, let's count my input table total records again. Okay, so we have a total record of 109. Let me make some changes. Okay, so I insert some rows as commit. Now let's back to our AWS Database Management Service Console. Start our task. To see just now all the changes I made for the source database will be successfully replicated to my target database or not. Now let's start job. Now job started and also replication ongoing. Since the ICN number I specified when I create this replication task, the only changes I made for my source database just insert 5 rows to my HR employee table. With that, this replication task finished very fast. You can see progress already 100%. Let's click a task. You also can go to the table statistics page. Can give us a clear picture under HR schema. All the tables, I only insert 5 rows to the employee table. From the summary page, you also can click View CloudWatch. And from CloudWatch, you can see here, Oracle capture start from stream position, exactly the ICN number we specified when we create this task. You can see all the detail step by step from CloudWatch. The last verification I want to do is I want to use SQL Developer connect to my target database. I'll check the total records in my HR employee table. Let's run this query. I got the total number is 114 exactly. I did 5 new more rows I created on my source database for this demo purpose. With that, you can see we can use AWS Database Migration Service and Oracle Data Pump to achieve near zero downtime migrate the Oracle database from on-premises or EC2 to RDS Oracle. Thanks for watching. Happy cloud computing from all of us here at AWS.